Hello.
Hi Anshuman, can you hear me?
Yeah, I can hear you. Are you able to see my screen?
Yes, the presentation is on.
Yeah. So I will just begin now. Okay.
Sure.
So good afternoon to everyone present here today. Thank you for inviting me to RNDC. It is really a pleasure to be here. And topic of my presentation is quantum decision making and human algorithm interaction in bureaucracy. So let us begin. Okay. So these are some important questions that I want you to keep in mind uh, when I'm delivering the presentation. So what is hybrid bias state in human algorithm interaction? Second question, any other subsystem of the mind that you can think of? Third, what is the no mind state according to you? Fourth question, what external conditions influence actualization of mental states? Okay, so these four questions you can keep in your mind when I deliver the presentation, and afterwards we can discuss. Okay, so as per various studies in UK and US, algorithms are actually discriminatory, especially against minorities. You know, the minorities are actually underrepresented in various databases, and those databases are actually used to train the algorithms. That is why algorithms are actually discriminatory. And this leads to phenomena like anti-blackness, or what people call as trained bias. We have trained the bias into the algorithms. And you can see general algorithms designed by Microsoft, Facebook, IBM, and you can see that there are very high levels of error rates in dark-skinned female, ranging from 20% to 35%. So this is a cause for worry. So gender classification is actually there are high error rates in gender classification, and not just in gender classification, even in race classification. So in India, you can see that we have a diversity of tribals, we have Dalits, Muslims, so they are all minorities and they can be underrepresented in Indian databases. So when we use algorithms, so we have an inherent trained bias in the algorithms themselves. So this is one major problem. And another problem is the that there is this problem of biases when human interacts with these algorithms. So this is called as human algorithm interaction. So there are different biases that arise during this human algorithm interaction, such as confirmation bias, order effect bias, black box paradox, and several other biases. In fact, one such study has shown that there is a superposition of mental states. So within the same bureaucrat, you can find both expertise as well as bias within the same bureaucrat, within the perception of the same bureaucrat. So you can see this graphic. In this graphic, you can see that in the 60% range, you can see that both biased and expertise was seen in most of the bureaucrats. In the same bureaucrat, he was taking decision as per his expertise, but at the same time, biases were also cropping in his perception. So some kind, you can say there was a superposition of, you can see that there was a superposition of both the unconscious elements and the conscious elements of his mind. So 47% in this study in the UK, 47% of bureaucrats, they showed elements of both bias and expertise. Then similarly, in another such study in the UK, in the police department, uh, there was entirely different kind of human algorithm interaction. And this author Fussy, he named it as algorithmic reification. So algorithmic reification is basically you are exploiting the algorithm for your own benefit. So you are using the algorithm as a technology of power. So this is a totally different kind of interaction that is happening between human and algorithm. So you can see that there is a superposition of mental states, and that is why in this lecture, we are discussing on quantum mechanics. Quantum mechanics or quantum physics can be used in bureaucratic decision making. Okay, so now why exactly quantum decision making, makes sense in the study of bureaucracy? So there are several reasons for it. The most important reason is contextuality. As I told you, there are order effects, right? So contextuality relates to order in which the information is received by the bureaucrat. For instance, suppose the bureaucrat first thinks on his own and then he looks at the algorithmic advice, in this order. First he thinks on his own and then he, looks at what the algorithm is saying to him. And this will result in some kind of decision, right? And however, if the order is reversed, for instance, first he looks at the algorithmic advice and then he thinks on his own, okay, or he takes the advice of his peers or his seniors. So the order is reversed, then it is seen that the decision is also changed. The decision is different. So this is called as the order effect bias. And we also know that in quantum mechanics, there is a thing called non-commutative operators. A, for instance, A multiplied by B is not the same as B multiplied by A. For A plus B, when A and B are both vectors, A plus B is not the same as B plus A. So that is why we can very conveniently we can use quantum decision making or quantum mechanics. We can model the human cognition with quantum mechanics. And second is unknowns. There are many unknowns, unknown variables. So unknown events, they also deviate policymakers from logical or rational decisions. For example, you must have seen that the export of wheat has been banned in India. So that is against neoliberal principles, that is against utility maximization, and that is against the rational perspective in policy making. But this is due to the various unknowns which we cannot measure, which the human mind cannot measure. For instance, the ongoing Ukraine war, the climate change, the heat waves, and the COVID pandemic. These things are beyond our beyond measuring. So these are the unknowns, and due to these unknown variables which cannot be measured, this leads to some kind of superposition of various mental states. And due to this superposition, the bureaucrats actually deviate from rational decision making. That is why, again, quantum decision making makes sense. So third is thinking fast in uncertainty. So, various psychological experiments conducted by Daniel Kahneman and others, they have already shown us that when bureaucrats think on their feet, or when any human thinks on his feet in uncertainty, there is system one thinking. And system one thinking is basically the thinking that comes from emotions, from the subconscious mind, and there are elements of fear, anger, anxiety inbuilt in the decision making, and there is not much reasoning. So uh, reasoning is a part of system two thinking. So system one thinking is activated when we are thinking fast in uncertainty. So obviously, quantum decision making can comprehensively cover most of the biases that come in when we are thinking fast and the bureaucrat is thinking very fast in uncertainty. So take for example, sudden lockdown that was imposed in 2020 because of COVID. So some experts believe that it was a very emotional kind of decision. You didn't take care of the migrants, and there was such panic across various cities in India. So one can argue that the sudden lockdown by the government, it was more of an emotional response. It was more of a system one level of thinking because of uncertainty of the pandemic. So again, quantum decision making makes sense in that way. So another point is that it is actually a complex adaptive system. And when we study complexity economics, we study quantum decision making. So since the complex adaptive system consists of individual bureaucrats, algorithms, and other bureaucrats in the vicinity. So this is the external complex adaptive system. And when we look inside the mind of the bureaucrat, there are again various subsystems. So in this theory, I have given 4 subsystems. So internal complex adaptive system as well as external, like beyond the mind of the bureaucrat. So there are 2 kinds of complex adaptive systems. So again, quantum decision making can be used to study bureaucracy. When we look at bureaucracy uh, in the perspective of complexity approach, the complex adaptive system approach. And then the other point is similar to this point, study bureaucratic mind in whole and not in parts. So obviously, when we earlier studies have focused very narrowly on certain aspects of the mind. For instance, either they are talking about a perfectly rational mind or they are talking about perfectly social mind. But in this study, we can, when we are using quantum decision making, we can actually study the mind in whole. We can study the biases, we can study conscious mind, we can study unconscious mind, we can study the social mind, the economic, the perfectly rational mind, which are very much part of the human mind. All these aspects are already there in the human mind, in the same human. So we can study this using quantum decision making. Therefore, quantitative quantum principles like non-commutative operations and the superposition, they can be applied to study the bureaucratic mind. So now we are very much clear like why we are using quantum mechanics, quantum physics, uh, to make sense of bureaucratic decision making. So all these points we can keep in mind, like contextuality, unknowns, thinking fast, complex data system, then need to study bureaucratic mind in whole and not as a reduction, not in parts. Okay, let's move forward. So let me just tell you the basics of quantum mechanics. So as we know that information in a quantum system is stored in qubits. We are not saying that it is only 0 or 1. In fact, it can be a superposition of both 0 and 1. And Hilbert's space is a mathematical framework that can be applied to in quantum decision making, in quantum cognition. When we are using a mathematical formalism, we can apply Hilbert space. It gives us a set of vectors, and it can go up to infinite dimensions and various properties like non-commutative operators. All these things we can use in Hilbert space, and we can actually show the superposition in Hilbert space. And quantum state of the quantum system, it can be represented by superposition of 2 raised to the power n basis state vectors, where n is the number of qubits. So in today's lecture, I have taken the number of qubits as 1. There is 1 qubit because I'm taking 1 neuron. So I'm actually modeling 1 neuron as a 1 qubit. So n would be 1 and 2 raised to the power n. So 2 basis vectors would be there. One basis vector corresponding to 0 and one basis vector corresponding to 1. Okay, let's move forward. This was the basic of quantum mechanics. Okay, so quantum decision making has been talked about in literature, since Niels Bohr, since 1920. But more recently, Krenikov has been a pioneer. He has even written books like Ubiquitous, Quantum Structure, and Quantum Social Science. These are the 2 books that have been written. They are very popular, actually. Many scholars refer to these books. And Krenikov has shown that quantum mechanics can be used in psychology, social science, economics, in various fields. But the first person who proposed the similarity between human cognition and quantum mechanics was perhaps Niels Bohr in 1920s, perhaps in 1925-26. And when we look at the correspondence letters between Pauli and Carl Jung, they have also shown they were actually corresponding with each other. Like Pauli was actually a patient of Carl Jung. Carl Jung is obviously was a psychoanalyst, a psychiatrist. So Pauli was having a difficult time in those days, some mental conditions. So he was actually corresponding with Carl Jung, and they were in those letters. Some scholars have studied those letters, and they are saying that there is a very good relationship between quantum physics and human cognition. And recently, there has been an interest in biology, in functional MRI, and now several scholars, they are proposing that the dendrites of the neurons, the synapses, they can also be considered, they can be similar to quantum cognition, and quantum physics can describe this neural activity which is happening in the brain, in the dendrites and the synapses. So this is really interesting. And so here again, like a neuron in human mind can be seen as a qubit. So this is the idea that we are taking forward into the next slides. Like a neuron in the human mind can be seen as a qubit. So when a neuron will fire, when the electric potential of the neuron is such that it is firing, we can consider it as the one, the state of one. And when it is not firing, when it is ideal, we can consider that it is zero. The qubit is zero. So, so this is an experiment. We can do this right now. So I want you to observe this image and just tell to yourself in your mind, like, what do you observe? So do you observe a vase, or do you observe two faces, or do you observe both of these things, these two things together? So you can just observe in your own mind, and you can ask yourself, is it a superposition of mental states, or what is happening? Why am I seeing, two images at the same time? And you can ask yourself, what will happen, if I focus on only the vase? Does the other image vanish? Does it collapse if I see only the vase? Or if I see only the human face, consider only the human face, then perhaps you will think that there is no vase. There is just a white background. So this is called as bistable perception. And several scholars in the field of quantum mechanics, like Krennikov, they are also actually mathematically proving like why and how this thing is happening in the brain, and why the unconscious mind is superimposing with the conscious mind. So this is one thing that we can take forward. Perhaps you have observed, and we will discuss it later. Okay. Okay. So just like we were saying earlier, the quantum-like representation of neuron. So this graphic is taken from Krennikov again. Krennikov has worked a lot in this field. So when the neuron is firing, it is at an electric potential, say plus 40. So we can consider that state to be one. And somewhere in the middle, we can say there would be a superposition. So you can say psi can be represented as a superposition of 0 and 1 of the two basis vectors. On the other hand, the neuron is lying ideal, it is sleeping. So you can say the psi is 0. So interestingly, when the neuron is firing, we can say that the conscious choice making is active. Okay. And when the neuron is not firing, there are several studies which show that the pattern of activity shifts from neocortex to subcortex. So when we say that the neuron is not firing, even then there would be some portions of the brain in the subconscious mind which will be active. So again, going back to Daniel Kahneman, it would be like saying that system one thinking would be active when a neuron is not firing. Okay, it would be an unaware mode when the neuron is not firing. So we can say that basis state of 0 would signify unconscious mind, and basis state of 1 would signify conscious mind. So you can also, if you are aware of Schrodinger's cat, you can actually refer to Schrodinger's cat. Like when you have not opened the box, you are not sure whether the cat is asleep or whether the cat is awake. So the cat can be in superposition of both asleep and awake state. So similarly, inside the human mind can be conscious as well as unconscious at the same time, un until the decision is made. So before the decision is made, there would be kind of superposition of the unconscious mind and the conscious mind. Or you can say the system one thinking and the system two thinking will exist simultaneously in the human mind, just like Schrodinger's cat. So now I am beginning with my hypothesis, my so-called theory. So I have taken inside the bureaucratic mind, I have taken 4 subsystems, and these subsystems are nothing but minds. So the human mind I have divided into 4 sub-minds or subsystems. So one is the ethical mind, this one, then the social mind, this one is the social mind, then third is the algo econ mind, algo econ is basically, the quantitative mind, the numbers mind, like the mind which focuses more on the technology, the techno-economic mind, and which is more utility maximizing. So third is the algo econ mind, and fourth is the administrative mind or the admin mind. Because we are studying the bureaucratic mind, so this would be a very dominant portion inside the bureaucratic mind, the admin mind. And since we are studying quantum principles, so I have divided each subsystem into unconscious and conscious, because obviously we have seen that there would be a superposition, kind of superposition between both these minds. So unconscious ethical, conscious ethical, similarly unconscious social and conscious social. Then third subsystem is unconscious algoicon and conscious algoicon. Then fourth would be unconscious administrative and conscious administrative. So we can use Hilbert space to look at the superposition, which will be given by the sum of the basis vectors. So this would be the superposition in each of the subsystem. Uh, and the 0 would represent to the unconscious mind, this one the unconscious, and 1 would represent the conscious mind, this one. So in each subsystem, we can actually apply superposition, the linear combination of both these unconscious and conscious vectors, and we can get psi, we can get this psi for all these subsystems individually. Okay, so this is, we will carry on this thought in the next slide. Okay, so if we want to physically know like where the neuron is firing inside the subsystem, so we can obviously use the probability density function. And as you can see over here, the white portion in under the curve, this white portion, this denotes the higher likelihood of conscious mind activation. As you know, this means the neuron would be firing. So when neuron is firing, it signifies that there would be the activation of conscious mind in this domain, in this white domain. On the other hand, when you look at the green portion on both the edges of this curve, you can say that there would be a higher likelihood of unconscious mind activation. Although conscious mind would also be there because it's a superposition, but we can say the likelihood of unconscious mind would be higher in this green portion, in these two green portions. So you can say that since unconscious mind can also be divided into biased and expert unconscious, so we can say that left green portion, suppose this left green portion is the biased unconscious, and the right green portion can be the expert unconscious. And expert unconscious, you can say it would be like an expert intuition. Although it is some subconscious, but it is not a bias. It is coming out of your own expertise, like the expertise of the bureaucrat who has worked 20, 30 years in bureaucracy. So he can probably experience expert unconscious mind as well. So probably this right green portion you can consider as expert unconscious, and the left green portion of the mind you can consider as the biased unconscious. But we are talking about only the subsystem of the mind. I'm not talking about the whole mind, only the subsystem, like this subsystem, this one subsystem. Okay, forward. Okay, so now when you consider these neurons, suppose this input layer is one subsystem and this hidden layer is another subsystem, you can see obviously they are going to interact. The subsystems, they are not isolated parts. Obviously in the mind, all the subsystems are interacting, right? So these neurons, they will interact with the neurons of another subsystem, and they are going to form product states. So this is the operator of the product state, and these two, like A product B. So these this can be represented in Hilbert space, and we can say that when both subsystems interact with each other, they can form product states. Let's move forward. Yeah. So this is a, it's an ideal type model that I have created so that you better understand. It's just for heuristic purposes. It's for understanding purposes. This is not actually what is happening inside the brain. It is just a heuristic. It is just a model. So I have taken, instead of 4 subsystems to create this, model, this cube, I have taken actually 3 subsystems. Okay, for simplicity, I have taken algo, econ mind, social mind, and administrative mind. So, and I have very conveniently, I have chosen only the exact states, the 0 and the 1. So for each there would be two possibilities for each mind. So when you consider all the combinations, you will get 2 raised to the power 3, so 8. So you will get 8 product states just for heuristic purpose. It's not the real thing which is happening in the brain, but just for heuristic purpose, just for your understanding, I have taken these 8 product states and I have named them as per their amplitudes, probability amplitudes at A0 to A7. And these 4 states that you see over here, A0, A1, A4, A5, these are the, I call them destructive HAI states, the destructive human algorithm interaction states. You will know why I'm saying that. And the states which are behind, these 4 cubes which are behind this, they are the constructive HAI states. And you will understand in gradually like why I'm saying that they are destructive and they are constructive. So these are the 8 product states. Let's move forward now. Okay, so now you will better understand. So these are the amplitudes A0 to A7 of all these product states. And there is some kind of superposition happening in each subsystem, say this Z or Y or X. So these can take values of 0 or 1 or anything between 0 or 1. But since I've taken an ideal model, so I'm just considering 0 or 1. Similarly for Y, similarly for X. And you can see that X is the algo econ mind, Y is the social mind, Z is the administrative mind. And within each mind, obviously, we have discussed that there would be conscious as well as unconscious for each of the minds. And both of these would be in superposition of each other, both the conscious and the unconscious. So then as I've shown you, we are taking products. So all these states in product form, you can say the product state in the mind. So we calculate the psi of every subsystem, and then we take a product of the basis vectors, of the basis states, the resultant basis states, and in their product we get this product state, psi x, psi y, psi z, and obviously this is the notation that we use in quantum physics and in Hilbert space. So this notation is there, and you can see that I have also named the mental states, and it was there in the reading material also why I have named these as such, from starting from hybrid bias to HAI satisfying state. And I'm saying that HAI satisfying state, since there is 1, 1, and 1, so I'm saying that this is the most happy state and the most satisfied state. So I'm calling it as the most constructive HAI state. On the other hand, when you have 1, 0, 0, I'm saying that it would be Bureau Algo Nexus, and I have named it Bureau Algo Nexus. It would be a very destructive state where algorithm, bureaucrats, the entire system is actually, corrupt. And, this is more of a Marxist perspective. And you can find all these things in the literature. When you look at the literature, Bureau Algo Nexus is there, algorithmic reification is there. This is also a destructive state. This would be something new, hybrid bias. I don't know much about hybrid bias. This would be new, although all the others are there in the literature. And HAI satisfying can also be considered a novel approach, although it is similar to what Herbert Simon and Carl Jung, and they have talked about this individuation and, satisfying everything, becoming happy. Daniel Kahneman has also shown that, when individual is satisfied totally, he's happy. So yeah, this is there in the literature, but some things novel you can find like hybrid bias over here. So this would be the product state. Okay, so just like I was telling you earlier, there's a desirability index that I've created. So I have used the number line, the real number line from -4 to +4, and the destructive HAI states you can find over here in the left side. The constructive HAI you can find towards the right side. And you can see that A0 is the hybrid bias. Right now I've placed hybrid bias as undesirable, but we can discuss perhaps hybrid bias can also be very much desirable. We don't know how it will behave. So yeah, this is the desirability index that I've created. It was there in the reading material also. So yeah, so we'll go forward. Okay, so the desirability scores, you can, I have included all the four subsystems, all the four minds I have included here in the Venn diagram. You can see clearly the ethical mind, the social mind, the algo econ mind, and the administrative mind. And inside each of these minds, you can again find that I have taken collective conscious as well as unconscious. So within these minds, I have again taken both conscious elements and unconscious elements. The important thing is to realize, to observe that these Venn diagrams, they are overlapping. So these overlapping are actually, we can say that these are the product states. Okay, these are the product states. And when all these Venn diagram, when all these minds are actually satisfied, so you get in the middle, you get the most constructive, the HAI satisfying state of +4, which I have scored as +4. On the other hand, when ethical mind has been circumvented, when the human is not ethical, you can see there is a state of there is a score of -4. This is actually the Bureau algo nexus state of -4. And somewhere over here, you will find hybrid bias. You will find all those product states that I've mentioned earlier. And you will always find infinite mental states, because there is nothing, you cannot label anything. I have just labeled all these aspects for your understanding, but there would be infinite mental states. And this unconscious ethical mind, I didn't know how to put it, so I have put it above. In the ethical domain, I've put it like all this portion which is emerging out of the mind. I think it would be like the no mind state, the unconscious ethical mind state. Roger Penrose and many other scholars are also working on this. They are calling it consciousness, and they are using different words for it. So I have used the word unconscious ethical, the no mind state. We can go into Buddhist philosophy or Taoism or Vedanta, or we can use multiple spiritual scriptures to understand like what is this unconscious ethical mind. And we can use several YouTube videos are also there of Jiddu Krishnamurti. Jiddu Krishnamurti is interacting with David Bohm and several physicists, and they are also talking about this unconscious ethical, which is somewhere beyond the mind. That's why I've placed this beyond the mind. This is the mind. These are the subsystems of the mind, and this is beyond. Okay, so I really don't know like how to process this. So, but I have put it over here. So yeah, you can go through this. This expert intuition, this is actually a part of the unconscious mind itself. This is not conscious. Expert intuition, since it is an intuition, so this we can see in very experienced bureaucrats. This expert intuition. But heuristics and bias is a part of the unconscious, is again a part of unconscious. And this expert intuition is also unconscious. But the bureaucrat can also behave as a conscious expert. So conscious expert state is also a desirable state. So I have used 0 to 1. This real number line I've used. This is also a desirable state. So likewise, we can discuss further on this, the mental states. Okay, so again, the similar Venn diagram I've created, and here I have shown the choice space. So this space, the tops, this can be said to be a desirable choice space, and he can be a Kantian mind. It can be a Kantian mind, it thinking too fast. It can also be a no mind, because when there is no mind, you don't you again think very fast, right? So when you are unconscious, you think very fast. So unconscious mind will also come here. So this is a desirable choice space. So here again, I have said that this would be a desirable choice space below this one. And this would be the human decision maker would be aiming for systemic satisfaction and thinking not too fast, not too slow. So when you are thinking not too fast, not too slow, you can make a desirable choice, and you can make the decision maker can make himself feel satisfied, feel happy about the decision that he has taken. And then bottom, you come to the third section. This would be the undesirable choice space, when the decision maker is stuck in systemic bias, in different kinds of bias and unconscious biases. So the decision maker is totally stuck. And this is probably because he's thinking too fast in uncertainty. For example, the pandemic or any other situation like like riots, which keep on happening in India these days. So the police is obviously stuck in systemic bias in those. They don't know what to do. They don't have standard operating procedure. They don't have the rules. So they have to think on their feet. So perhaps they will be more biased when they are using algorithms in such situations. And then obviously we have the algo econ mind. The algo econ mind, it would be, you can say they will be able to perceive the algorithms in the right manner because they know what is happening. For them, the algorithm is not like a black box. They are very much aware of the algorithm. So they would be like utilitarians. They would be rationalists. They would focus more on the quantitative aspect, the numbers. So this algo econ mind, or we can say algo econ man. So this again would be a desirable choice space. And in between this space, I have labeled as undesirable. By undesirable, I mean the destructive human algorithm interaction. And by desirable, I mean constructive human algorithm interaction. So perhaps you have understood this. Let's move forward. We'll discuss this later. Okay, so these are some of the research questions I have in my mind considering my thesis. So I would want to know like what are those external conditions which promote actualization of desirable mental states. By desirable, I mean constructive HAI. And then I also want to know what will be those external conditions which promote actualization of undesirable mental states, like the destructive HAI. So those external conditions can be, anything. It can be the political environment. It can be the discretion that is given to a bureaucrat. For instance, police has a lot of discretion. They have a lot of power. Perhaps they would have a different kind of actualization of their mental states because they are so much powerful and they are having so much of discretion. And similarly, we have bureaucrats working in welfare services, in children's services and healthcare. Perhaps they will have a different actualization because they have different external conditions. Perhaps different decisions or different duties. They will have different actualization of mental states, even though mental states of most of the bureaucrats would be the same, but the actualization can differ because of the environment, because of the context, because of the external conditions. So I would want to know like what are those specific conditions then that encourage desirable mental states, and what are those conditions that result in undesirable or destructive, HAI mental states. So these would be my research questions going forward in my thesis. Forward, we'll discuss each of these. Yeah, so policy implications, you can say that once this research or these kinds of research happen in India, we will be able to interpret, the algorithmic advice, and bureaucrats will be more, you can say, more aware of the algorithms and the advice the algorithm is giving to them. The algorithm will no longer be a black box. Algorithm will be familiar. The bureaucrats will be able to understand what is happening inside the algorithm. So this is a very important implication of such a study. Then there could be some systemic reforms that can be brought. Certain conditions can be favored so that constructive human algorithm interaction takes place through systemic reforms, not just reforms in bureaucracy, but reforms all around, reforms in politics, reforms in education, and so on. So systemic reforms can be brought about through this study. Then obviously there will be a change in administrative training. These days we are focusing more on the how to implement the policies, but we are not focusing on the technology aspect. But this has become the truth of our lives. We are living in the digital age. We are living in the age of AI. So administrative training should include artificial intelligence, machine learning, and also the ethical components, the ethical dimension of artificial intelligence, AI bias, and so on. Then human and algo bias. So yeah, so human biases are there and algorithmic biases are there. So bureaucrats will, because of such studies, bureaucrats will be more aware about their own biases and about the biases that are present in the algorithm. And what are those kind of hybrid biases that are coming when human interacts with algorithm? So bureaucrats will be more aware of their biases when we do such kind of studies. And obviously, it would be an emergence phenomena. And when bureaucrats are more aware, they can give constructive feedback to Google, to Facebook, to ISRO, Indian Space Research Organization, all those entities which are actually creating these algorithms. So we can ultimately hope to design, fair algorithms and more responsible artificial intelligence in the future. And it can lead to better decision making, desirable states, desirable mental states, and a more constructive human algorithm interaction. So this is again a very important implication of such a study. And these are some of the references that I have used. You can find Krenikov a lot, like here Krenikov along with Sudeep Patra sir, and you can find Sudeep Patra sir over here also, and you can find Krenikov. You can find Nobel laureates like Herbert Simon, who gave the theory of the bounded rationality. All these things started picking up after he gave his bounded rationality in 1950s. So yeah, so you can go through these references. These are very interesting. And there are some studies conducted in India as well by Marda in JNU. So they are talking about the data biases. They are not talking about algorithm, but they are talking about data biases in New Delhi's predictive policing system. So yeah, so you can go through all these references. One interesting reference is also Thea Snow. Uh, she is also a director of a center in public policy in Australia. So she has conducted various studies in UK, US, and in Australia. And she is also saying that there is some kind of superposition, and the expertise and the bias components in bureaucrats, they are actually superimposing onto each other. So she is using the term artificing, from satisficing to artificing. So what I am saying as human algorithm interaction, she is saying that it is artificing. So yeah, so these are very interesting references. You can go through them, and we can discuss on them further. So yeah, I would like to thank you for your time, for your patience, and we can just have comments on some of these questions, uh, and we can move the discussion forward. So if anything anyone wants to say, you can say. You can give me some feedback, any comments, what you liked in the slides, or what can I
Yeah, so
differently on some of these questions. Yeah.
okay, so thanks a lot for your very interesting presentation. So let us first hear from Teshta, Ajit, and anyone else who is attending. Then perhaps I can come back.
Yeah. So
So,
Cheshta, Arijit, you can either you can try to we can discuss on these questions, or you can also comment anything that comes to your mind regarding my presentation.
Sure, I'm sure. Thank you for the presentation. I found it very exciting, but I just have two clarification questions before we move on to the question answers.
Yeah.
So first, I mean that might be very basic one, but I just wanted to know whenever we are doing this mapping and saying that quantum making mechanics can be used for making the distinctions between the bureaucratic minds, etc., using the Hilbert space. Have you taken, I mean, was there a sample size involved where you did, I mean, involve the bureaucrats very explicitly in the study and then you found out this divisions? That's my first one. And the second one is with the policy implications, while you said that the human and algo bias awareness should also be there in the bureaucrats, which would help us in coming up, making some effective results from this study. How can this be imposed in a country like India, where we know what are the qualifications of various bureaucrats? So how is this possible, or how can this be made effective in a country like ours? That's my second one.
Okay. Thank you for your questions. Very good questions. So I would first like to answer your second question, like why I said that human biases and algorithmic biases, they should be studied. So basically, as you know, that there are several human biases, such as the confirmation bias, the order effect, that come in when bureaucrats interact with algorithms. But in India, we are just starting with algorithmic decision making with AI. So right now we do not know much, like how bureaucrats in India are going to address these challenges of bias, because we have seen these biases in UK and US because they are ahead of India. They are like well ahead, like 15, 20 years ahead of India in terms of adopting algorithms. So when it comes to India, there is obviously very little sensitivity towards understanding bureaucratic biases, let alone algorithmic bias. Algorithmic bias would be there in India, as I told you before, that in India we have a diversity of communities and we have minorities who are not well represented in any of the databases. So when we are training the algorithm using using that data, there would be some kind of trained bias and discrimination against certain minorities, certain communities in India. But again, as I told you, in India we don't have too much research going on in this field. In JNU, they have actually used the data. They have studied data in India and how it is biased, but we have not really used algorithms, the predictive policing algorithms that the police is using in Delhi NCR. We have not studied that as of now. So my thesis is oriented towards studying those predictive policing algorithms and towards studying the police behavior in India. So I have already given you an example of UK in the how the police is behaving in the UK, and it is leading to algorithmic reification. Like they are using algorithms arbitrarily, to point out certain communities and just to fulfill their own agenda. So, you can find similar things in India as well. Although this, again, this would be like many students are actually simultaneously working in India, but right now we are not having a published, research on human algorithm interaction in India. But as we delve into the subject much deeper, obviously it is going to help in India because, as I told you, in administrative training, whether it's in Labasna or any other institute in ISB. So we are gradually moving towards understanding the ethical dimensions of AI. And as these studies come up, probably Government of India will also institute specific, algo training or understanding machine learning within Labasna, within, the basic training that the IAS officers and the police officers in Hyderabad that they get. Probably they will include such kind of studies that we are doing right now, and that can help a lot going forward. And I would request you to kindly repeat your first question.
Okay, thank you for this one. Actually, my first question was when you were modeling to the Hilbert space while we were dividing the
Yeah.
exercise, what really the bureaucrats involved in the study? I mean, on the basis of their answers, or how was this modeling used? That was my.
Okay. So basically, this is at a very early stage. I have not actually modeled. I have not used any mathematics. As you can see, I have talked very little about Hilbert space. I have just referred to it. But I think that, I have studied various papers, and I really believe that some kind of superposition is happening. So, but I don't know how to model that superposition, how to model those inconsistencies in choice making. So there was a slide on inconsistency. So I will show it to you. So there is this problem of inconsistent choice making in human algorithm interaction. So I have actually taken this data. This is not my data. This is a paper from Thea Snow. So she has done this study in the UK. These studies are not done in India actually. So I have just carried forward the idea to India. So, and I have not even done any quantitative this quantum modeling. I'm just using it as an analogy to better understand how to predict human behavior, or you can say how to create a framework to understand different kinds of choice making that happen. But these choice making that is happening, it's very inconsistent. In UK, if you see the same kinds of bureaucrats, in the UK, in children's services, they are having uh, totally different choice making, and they are having the superposition between bias and expertise. But in the same society, in the UK society, if you look at the police, who are having a lot of discretion, they are having a totally different kind of interaction. They are having algorithmic reification. So how do you actually create a framework for such divergent choices? At the same time, you are having algorithmic reification. At the same time, you are also having biases and expertise you can see in choice making. So that is why I wanted to use quantum modeling. Although this is just an analogy, I have not actually taken some data or survey right now. Although I plan to do a survey in Indian police in Delhi NCR specifically. So I want to like create a psychological survey for that. Then we can perhaps know better like what is the actual situation in India. Right now, this is just you can say hypothesis. This is yeah, that's all.
All right, that makes it clear.
Yeah, great. Any other question, Arjit?
Yeah, I actually had a few questions to ask. So,
Yeah.
first of all, are we looking at the effect of algorithm in justice now? Is that what we're trying to do with this? Because I get the bureaucracy and the bureaucratic mind and all that, but when you put an algorithm into it, I'm thinking of AI. Now, are we looking at AI, or is that some, if I have I missed
Yeah.
something?
Yeah, that's a good question. So I would like to answer that by using this model itself. So when you look at this subsystem, this mind, so I have taken a separate, part of the mind, which I have called as algo econ mind. So this algo econ mind, the information from the algorithm I think it will first arrive in this portion of the mind, the algo econ mind. And it depends upon the awareness and the training of the algo econ mind. How they perceive, how the bureaucrats perceive those algorithms, because algorithms can be discriminatory, but they can also be very efficient, and they can also be very neutral. You don't know whether the algorithm, it's a black box. You don't know whether the algorithm is fair or whether it's unfair. So I would say that the algorithmic information that we are getting from algorithm, that will first enter the algo econ mind. It will not enter any of the other minds. And as per the training of the bureaucrat, as per his own expertise in dealing with algorithms, and suppose he is very techno-economic man, and he believes in quantitative numbers, he believes in utility maximization, and he has studied he has done some master's degree in machine learning, in artificial intelligence. Then perhaps that kind of bureaucrat who is having an active this kind of subsystem, he will be or she will be able to do justice to the algorithm, because the algorithm is a black box. Algorithm can be fair as well as unfair, but ultimately how the human interacts with the algorithm using the algo econ mind, that will ultimately decide the mental state. So obviously, the algo econ mind will not be the only mind. The algo econ mind will have other kinds of minds working, the subsystems. For instance, the ethical, the social, the administrative. So ultimately, there will be many mental states. But first, as you asked, how the algorithm fits into this. So algorithm, I think, will fit over here, the subsystem, this third subsystem of the algo econ mind. I hope I make myself clear.
Yeah, and actually one more question. So you just mentioned that the algorithm is like a black box. You put in some input, you get some output, right? So in such a situation, wouldn't it take significant amount of skill for you to understand and interpret what is going on? So you've showed me a function, you showed me a density function, so I can't make sense of it. But then again, I have not done such level of statistics. So would it be a fair assumption to make that whoever is reading this will be
Yeah.
reading it correctly? And secondly, I'm pretty sure if a politician looks at this, they'll have someone else who'll do all this background work for them. So isn't there going to be some form of Chinese whisper going on? So the person who reads it will say something, and when he interprets it on his own and gives it to you, that would there will be some form of distortion in data. So how would you control for that?
Yeah, so that's a very good question. So basically, it's a very complex, it's a very complex adaptive system. It's difficult to control. Actually, it's very difficult to do this study. To design a particular survey and to say that only this particular bureaucrat was influenced by the algorithm, and the bureaucrat was not influenced by the whispers, as you say, or how the bureaucrat is actually interpreting the black box. Because since it's a black box, so the society does not know. If the society does not know, the bureaucrat also does not know, right? So yeah, it's a very valid question. It would be a difficult task to actually create specific surveys and psychological surveys in bureaucracy. And anyway, it's very hard to get bureaucrats to answer to any of your questions, especially when you are dealing with police. They don't answer your questions. So that would be a challenge for me going forward, and especially how to, just like you said, how to control the extraneous variables that will come in. So yeah, going forward, I will take that into account. Right now, I think I will not be able to do justice to your question, but I will definitely write it down. Thank you.
And one final question. I'm not trying to attack your research or anything. I'm pretty sure this is very good and it's very well made. But if you are unable to interpret what you're doing with all this labor and all that, you've done all the efforts you put in, how is it exactly useful for a person if you can't understand what you're doing? So I'm pretty sure it's a very elaborate method we God's gift to earth, but if you do not understand what's going on, how is it exactly helping society or
Yeah,
anyone for that matter?
yeah. So this is a criticism that quantum mechanics has been facing, and quantum social science has been facing the same kind of dilemmas. Like when you don't understand quantum mechanics, how do you actually do research, and how do you convince the government and the bureaucrats? So this is an ongoing debate, but I think it is useful because when you look at the heuristics, these tell a story. If you can consider this kind of heuristic, that 8 mental states, that product states that we have created, and we are saying that some of them might be destructive, some of them might be constructive. And when you give a logical explanation, when you give analysis, when you give examples to prove your point, when you give examples from all over the world that this is happening, this is algorithmic reification can take place, and this confirmation bias or order effects do play a role in human algorithm interaction. So this is kind of a framework, you can say. So you don't have to totally understand what is quantum mechanics. Okay, you don't have to understand that, but we can see that quantum cognition can be used as a framework to understand that a human is capable of anything. Human mind is capable of anything. And to apply that to convince bureaucrats, we can say that these are certain conditions. Like if you change these conditions, the actualization of mental state will change. So they can consider that, because you are giving examples, you are giving analysis, and they will understand. They might not understand the mathematics, they might not understand what is quantum, but the framework that you are giving, if you are telling a bureaucrat, simply, this A4, what is this, he will understand, she will understand, right? They don't have to understand exactly what is happening in the quantum cognition space. So yeah, that's what I want to say.
Makes sense. Thank you.
Yeah.
Okay, so from my side, I will say that it's a really a very good attempt.
Yeah.
Now, a couple of points I would just like to mention, and you see the technical points about mathematics, etc. We have to discuss.
Yes, sir.
That we will continue. Maybe this coming week we can sit together and kind of try to do some things to
Yes.
this particular, because as far as I see that these four subsystems that you're coming up with, that is very, very interesting. Yeah.
Yes, sir.
And also, yeah, that box, yeah, that thing. This Venn diagram is a different thing that
Yeah.
I don't think it really goes with quantum-like modeling, but
Okay.
the boxes are very interesting. That thing, earlier slide. Yeah, yeah, this thing. So
Okay.
this we need to work on this, and this can be really a kind of like a concrete model that, Arjit was also pointing out to the same fact that if you have a concrete model, then
Yeah.
perhaps you will be able to convince people much more.
Yeah.
And here for Arjit as well as Cheshta and you also, I will say that there are a lot of empirical works going on in this particular field. I will be glad to share the empirical papers with you. Myself, I am more a theoretician, but there are many people who are working on empirical grounds. So they
Okay.
are really crunching the data. So whether it is, financial sector or maybe administrative sector, there's something called as quantum Bayesian network, which is a kind of like a very interesting thing that has happened. So I know some of my friends are working in that area. So there is a very good communication going on, as Arjit was raising that very important question, that how would you like to communicate this to the wider society to,
Yeah.
convince them that what
Yeah.
value you are adding. So I think that if you refer to that empirical literature, many
Yeah.
people will get attracted, because
Yes.
the numbers speak. You can
Yeah.
show that, well, you see these things are happening. And I will give you some very specific references on that, who have tried to do this kind of empirical works, like what you are suggesting in this mental states in quantum like modeling.
Yes, sir.
So I will just mention all the names to, I will circulate to all of you if you are
Yeah.
interested.
Yes.
Another thing, just overall, I will say, because we have to work a lot in the
Yeah.
math part of it. Overall, I will say that don't use the word quantum physics directly,
Okay.
because it is better to use quantum cognition as you are using, or quantum decision theory. Or
Okay.
if you want to be very pragmatic, as I always become at times, you just use quantum like model,
Okay.
quantum like, because
Yeah.
you see that hardcore quantum physicists, they may kind of ask that in what basis you are saying that human brain is quantum. You
Yeah.
see, Penrose and Hameroff has studied that for a long time, but again, their research is still inconclusive. So we don't want to go in that area, because that will create unnecessary confusion. Better to say quantum like.
Okay.
Basically, you see this Hilbert space modeling that you're talking about.
Yes.
Hilbert space is basically a mathematical language, and that can be used in different areas. So quantum mechanics historically has been an area where Hilbert space modeling has been used up to good success.
Yes,
But
sir.
that doesn't mean that it cannot be used in other areas. And cognition can be very well be one such area where Hilbert space modeling is used, as you have mentioned.
Yes.
And particularly, I will give one reference to the model that Professor Partha Ghosh and I have I've just constructed on Hilbert space modeling of human cognition. And now it is getting accepted also. We have got publications out of that, good publications. So I will forward that model to you, and maybe we can discuss a bit on that particular model. And I see that since you are interested in contextuality, and
Yes.
contextuality is your like basis of your framework, that model might fit well. So these are some of the points that I would like to make. Otherwise, I should say it is an excellent attempt. People need to move in this kind of interdisciplinary areas. I will be happy to discuss with all of you, Arjit, if you are interested, and I will send you some specific references. But carry on. That's quite hopeful.
Yeah, thank you so much, sir. It would be great if you can share the
Okay, yeah,
references.
sure. I will do it right away.
Yes, Professor, I'd like that.
Okay, sure. These are the areas that we need to move into. Interdisciplinarity will, and also a lot of questions will come up, which perhaps even hardcore quantum physicists would also not know, because since you are interacting with social, that takes you into a completely new realm.
Yeah, it's really interesting, sir. Amazing.
Okay, so it was great interacting with you, and we'll keep on discussing.
Sure.
So now, Cheshta, we can just call it end.
Yeah.
Yes, Professor Patra. I think we're already 11 minutes ahead, but I think that was a great session and a great discussion. Thank you, Anshuman, for doing this for us and agreeing to give an RNDC. We had few participants because many students are busy with their exams, but we will post the recording on the CESP's YouTube channel, and we hope that we get a greater engagement from them.
Also, I will just request both Arjit and Anshuman to participate in all the Zoom discussions we might have with external partners. So whenever there is a scenario that students can also participate and raise their questions, please do that. So Cheshta will be circulating all the, for example, very soon I think we will have a good interaction with an institute. So maybe you both can also participate and raise some questions. Okay.
Sure, sir. Thank you. Yeah.
Definitely, Professor.
Yeah. Okay. So take care, and
Take care.
okay, we'll continue discussing. Yeah.
Sure. So thank you for having me. Thank you for inviting me to RNDC. It was really great. Yeah. Thank you.
Okay. Bye. Bye.
Thanks, Anshuman. Thank you, Professor Patra. Thanks,
Bye.
Arjit. Bye.
Thank you, Cheshta. Bye.
Bye.
Thanks.